Hello everyone. We are looking at determinant chapter, phase 5, exercise 1, and basically questions from our package. This is question number 31. Okay. Let's look at the question first. Question is, matrix is given to us and we have to prove a relationship. Okay. We can find out A inverse, we can find out A square, we can go ahead and do that. But I would want to use Cayley-Hamilton theorem here and find the characteristic equation and go ahead and use the theorem that the matrix will also will definitely satisfy the characteristic equation. It will be just easier for us to do that. We can always do like how we have been doing so far now. But here, I would just want to explain the characteristic equation. So if a matrix is given to us, the characteristic equation is x into I, determinant is equal to 0. So we will not go into the detail of how it comes, but this is the characteristic equation of this matrix. This is the characteristic equation of the matrix. And from Cayley-Hamilton theorem, we know that the matrix will satisfy this equation. So we'll see how it is going to help. Now, first of all, let's find the characteristic equation and let's see whether it is matching with it. So we will directly write 2 minus 1 because we are subtracting from xi. So only the diagonal elements are going to be affected. So minus 1, 5, 1 minus x, 0, 0, 1, 3 minus x. And let us equate this to 0. This will give us a polynomial. We can easily see it. We are going to get a polynomial in degree 3, which is what it should be. If it is a 3 by 3 matrix, we'll get a 3-degree polynomial. So if we just expand it, so 2 minus x into 1 minus x into 3x. So 1 minus x into 3 minus x, and basically this is 0, so we can directly write, and minus 1 into 5. Okay, and this is equated to 0. So we can just multiply it. Let's do it one by one. So minus x square, and minus 2x and minus x. 1, 3, okay. So minus 3x and plus 2. And this is multiplied with 3 minus x again and minus 5. Okay, multiplying with minus 3 here. So minus 3x square minus 9x plus 6 minus x cube minus plus x cube, and then minus ka plus 3x square, and then minus 2x minus 5 is equal to. So what do we get? X cube minus 3x square plus 3x square. All right, sorry, this is plus because minus minus plus, so 3 is, this is also plus, and that should make this minus cube. So minus plus 3x square, and this is minus 2x. Fine. So minus x cube plus 6x square, then minus 9 minus 2 is minus 11x, and then plus 6 plus 1 is equal to 0. So just let's make it in this shape. X cube minus 6x square plus 11x is equal to, all right, so plus 1 or minus 1 is equal to 0. All right, minus 1 is equal to 0. From this theorem, Cayley-Hamilton theorem, we know that the matrix is going to satisfy this equation. So a cube minus 6a square plus 11a is equal to 1. So is equal to I. Okay, so this is a characteristic equation of the given matrix, and our matrix is going to satisfy this. How does it help us? How does it help us? So let us find A inverse from here. So multiply everything with A inverse. So multiply everything with A inverse. So let's say A inverse here, A inverse here, A inverse here, and then another A inverse here. So A inverse into I, this is A inverse. And then 11 into A inverse is 11I. Then A inverse into A square. So A inverse into A, this is minus 6A. And then A inverse into A, 1A will become I. So this is A square. So if we solve, this is nothing but what we have got on the other side. So this is A square minus 6A plus 11I. And this is equal to A inverse. So what has happened here, if we are able to find the characteristic equation of the matrix, then we can find A inverse and multiplying with A inverse on both sides. So this is another method to find the A inverse. We know how to find A inverse. Take the adjoint, divide by the determinant value, and then go ahead. But this also we should know. This comes in handy most of the time. Okay. Thank you.